Greetings friends, and welcome back to the third week of the homework series in probability and stochastics. Today we'll be working on homework 3, problem 1. So here we have, let the probability of x equals k equals b times k times p to the k minus 1, and k can go from 1 to infinity, and where p can be greater than 0 but less than 1. So the first one asks us to find b so that the probability of x equals k represents a probability mass function. And what this is that we just have to set this equal to 1. And if we do a little math manipulation here, we can toss b to the other side, where 1 over b equals to the summation of k times p to the k minus 1. Okay. So if we look at the basic series, we have the summation of p to the k, where k equals 0 to infinity. That will give us 1 plus p squared, so on and so forth. That will give us 1 minus p to the k plus 1. And the reason why it will simplify to 1 over 1 minus p is because we have p that's greater than 0 and less than 1, and that'll give us a little decimal number. And since k is being taken to infinity, this will just outright cancel into 0 because it's just very small. So if knowing this, we can also say that k times p to the k minus 1 is equals to 1 over 1 minus p squared. And we can also basically sling this guy here to here, and all we have to do is just throw back in b more or less. And so b will equal to 1 minus p squared. So this is really important in basically for the next few questions here. So b asks us to basically find the expected value. And so we have the summation of k times p, k times probability of x equals k, and we'll set it equal to the summation of b times k squared with p to the k minus 1. We are basically getting our k here from the fact that it says, give me a second, OneNote's crashing. We'll open that again. We basically get our k from up here. It says, let the probability of x equals k. Cool. So taking from a, we know that the summation of k times p to the k minus 1 equals to 1 over 1 minus p, and we want to multiply p by both sides, so we just get the summation of k times p to the k, and here we get p over 1 minus p squared. And we'll just derive both sides by p. You just use the derivative calculator and you'll get this guy here, and this side here as well. It just becomes k squared times p to k minus 1. And if we add back in b, and which we found out equals to 1 minus p squared, basically this here will cancel out to 1. OneNote's acting a little fishy today. Give me a second, would you? So it'll cancel out to just one, easy as that, and that's our expected value. And if we want the expected value of x squared, remember how they said the probability of x equals k. We'll just, if it's x squared, then it'll equal to k squared. Simple as that. That's why we have this here. So multiplying this all out, yes, remember it also says equals b times k times p to the k minus 1. We're just playing a little substitution here. We get b times k cubed times p to the k minus 1. And we're basically taking from p again. We get this guy here from, what happened here? From this guy here. And once again, we multiply p by both sides. Bust out the derivative calculator again. You'll get this guy here, and tossing in b, you'll get 1 minus p square. And for d, it's quite easy. You have the expected value x square minus e square to the x. So basically, give me a second. Wow, OneNote really is acting a little janky today. Yeah, sorry, bear with me. There it is. Okay. So our D, we have all we need to do for this one. Very simple. We found out our expected value is just 1 plus p over 1 minus p. So this here is literally just the same thing, but both of these values are squared. And just doing simple maths, you'll get 2p over 1 minus p squared. So E, it calls for us, it says let p equals 1/3 and find a conditional probability mass function where p x probability of x equals k is condition of 2 is less than or greater, no, less than or equal to x, and x is less than or equal to 5. So breaking this down, if we have p is equal to 1/3, then it should hold that with the formula that we know, b is equal to 1 minus p squared. That'll result in 4/9. And the probability of x equals k will equal to 4/9 times k times 1/3 to the k minus 1. So here we have this little equation here. You have the probability of x equals k is condition of x is between 2 and 5, and this equals to probability of x equals k, and 2 is less than or equal to x less than or equal to 5 over probability of 2 less than or equal to x less than or equal to 5, and that will give us this here. We're basically turning the denominator, translating it into summation of 2 to 5 of probability of x equals to k. And so we have our condition here, basically if k equals 2 to 5, we basically have our answer here, 409 times k times 1/3 to the k minus 1 over 0.538, which is basically what this is. And any other value of k probably just equal to 0. Thank you for watching, and thank you for bearing with OneNote being a little feisty today.